Okay, class, this is going to be the first video in the next class, which is the Active Directory class. So the first thing I'm going to do is I'm going to go to www.acitlab.com. You have to type the www. I am using Chrome and I'm not using Internet Explorer. You're going to type your email address and our standard password. So the first time you come in, you're going to choose the drop-down lab. You're going to choose the lab for this class and say copy to my labs. From from this point on, every time you come in, you're just going to go to this lab. You're not going to recopy it. You only need to do that once. So once you have it copied, I'm going to activate that lab. You can only activate one lab at a time. So for this first lab, the machines that we need booted up are parent DC1, NAT1, NAT2, and parent DC3. So those are going to take a few minutes to boot up, and while they are, I'm going to go over to D2L, and inside the course, we have, under ACIT Labs, we have our network map. I already have it opened up here. So what we're going to do is configure this computer, these two routers, and this computer. Basically, um, setting up sites in an Active Directory environment allows us to control replication between two site links. Say like between us and Central Campus and North Campus. The school doesn't control that link. That's actually controlled by our ISP. And so we have to pay for all that traffic that goes over that link. So you want to minimize what traffic goes over that link and when that happens. And we do that by defining sites by geographic location. So the west site will be one geographic location with a fast internet connection, and it would be connected to another site called east site that has a fast network connection, and they're linked by some sort of slower WAN technology. So that's what this link right here would represent. This link is actually going to be controlled by our ISP. It's called Black Box. We don't know how they do it. There's a bunch of different technologies that your ISP could use. All we're really concerned with is them providing the connection. We don't care how they provide it. We're just concerned with that actual connection. And each of those routers is also connected to the internet. So if this link right here goes down, this router could route traffic across the WAN link out to that internet connection. In the same way with this. If this link goes down, this site over here could still reach the internet by going across the WAN link and out there. Otherwise, the west side will use this interface to get to the internet, and the east side would use this interface. I've already subnetted each subnet out, so each subnet can hold 2,000 hosts, 2,000 hosts, and this one will only hold 2 hosts, one there and one there. So when everything gets booted, we're going to start configuring these routers. So while this is still booting up, I'm going to pause the video. Okay, so NAT1 is booted up. So I'm going to, you can see if I have NAT1 selected. I'm going to sign in. while the desktop is coming up, you're going to see that I have a public interface, an interface attached to the west site, and an interface attached to the WAN link. So I have three interfaces. The public interface will be dynamic. My ISP will give me an IP. For the west side, it'll be 172.16.0/21. And for the WAN side, it'll be 172.16.61/30. So I'm going to go to local server and click on any network card. I have three network cards. If I double click this one, detail, I can see I get a public IP. So I know that's my public interface. See, this says unidentified network, unidentified network. It's not always going to be adapter 3 for you. So the one that actually has an IP address that starts with the 10, that's your public network. So I'm going to press F2 and call that public. Now I'm going to go back to lab. I'm going to expand my net router, and I can see the MAC address ending in 55 is attached to West. So I'm going to go back to my console. This one ends in 55. So I'm going to label that West. Hit the tab key. So this one must be WAN. So I'm going to first assign an IP address to West. Going from my network map, 172.16.0.1/21. /21 would be 255.255.248.0. When I look at my network map, this router has three interfaces. Only one of them gets a gateway. The interface closest that it goes toward the internet gets a gateway. So this interface and this interface won't get a gateway. I don't have these configured yet, but the DNS servers for this router will be 0.2 and 0.3 once I have it fully set up. So for right now, I'm just going to put in those IPs. Click OK. I'm going to do the same for WAN. Now my IP address will be 172.16.16.1/30. /30 would be 255.255.255.252. Again, I don't get a gateway because my public interface gets a gateway. And I'm going to use the same DNS servers. Click OK. So I'm going to go back to my map. This machine will use these two DNS servers. This machine over here will use these two as DNS servers. We don't want to have this machine go across the WAN link to talk to these DNS servers. That's just going to drive up our bill because every time we send more data through that WAN link, our ISP is going to charge us more. So we want to try to keep as much traffic local as possible. These machines will do all the name resolution on this site. These two machines will do all the name resolution on this site. So after my IP is configured, I'm going to rename and reboot. This will be NAT 1. Now I'm going to go over to NAT 2 and do the same thing. So again, going back to my map, I have three interfaces, one attached to WAN, one attached to public, and one attached to East. The one that gets an IP address is public. So I'm going to go back to my lab. I'm going to expand that 2 and look at the MAC address. The one that ends in A8 for me is attached to East. I'm going to go back to console. So this one ends in A8, so that must be my East. Again, it'll be different for you. I just hit the tab key and rename that one. So for East, my IP address is 172.16.8.1/21. I don't get a gateway because the gateway will be on my public interface of this router. And my DNS servers will be DC3 and DC4. I'm going to have this router use these two machines for DNS. I'm not going to have it go across the WAN link to connect to these two DNS servers. Can you imagine that every time we needed to resolve a name on Central Campus, they sent us to the North Campus? It would be too costly. So I want to try to keep that name resolution traffic local. 172.16.8.2 and 8.3. And for my WAN link, it is 172.16.16.2, the second IP in that subnet. That subnet only has two IPs. The first one is 16.1. The second one is 16.2. And it's going to be a /30 subnet mask. No gateway, and using my local DNS servers. I should have done this on the first machine, but we'll do it now. For both machines, I want to open up the firewall on these two boxes, NAT1 and NAT2. We don't have to do it to any computer part of the domain because when we join it to the domain, it opens it for us. But I'm going to go back to NAT1 and do this same thing. Go to Tools, Windows Defender Firewall with Advanced Security. Go to Inbound Rules, and you're going to go down to File and Print Sharing Echo Request. There's two of them. Enable the rule. and do the same thing for outbound. We need to do this for NAT1 and NAT2. So I just did it for NAT2. I'm going to rename NAT2 and reboot it. I'm going to go back to NAT1 and sign in. I'm going to open up the firewall just like I did on NAT2. Inbound rules. Go down to file and printer sharing, echo request, enable rule. And the same for outbound. The two NAT routers will not be joined to the domain, so you have to manually open up the firewall rules. So let's install routing and remote access on both these routers. That's not it. Remote access. Routing. Add the tools to manage routing. Click next. Restart if needed. Install. I'm going to do the same thing to NAT2. I'm going to go to manage. I got to wait till this is done. Add roles and features. Click on routing. Sometimes when your mouse freezes up, if you go to another machine and come back, it'll unfreeze. I'm going to choose routing. Add the tools to manage routing. It also adds a web server because of the direct access, which we're not going to use. Restart if needed. So I'm going to wait for that to finish installing. Okay, it's installed on NAT1. So I'm going to go to Tools, Routing Remote Access. I'm going to highlight the server. Right click, Configure and Enable Routing and Remote Access. And we want to turn this into our NAT router. It's asking which is my public interface. We're going to choose public. It's asking which interface do we want to share our internet connection with. For right now, we're going to choose West and then add WAN once we get inside. Then finish. So I'm going to highlight NAT. I want to drill down into NAT IPv4, not IPv6. IPv4 NAT. I'm going to right click and add a new interface. I'm going to add the WAN interface. And it's going to be a private network, not attached to the internet. So the next thing we need to do is look at our routing table. So this quad 0 route right here represents the internet. So if you have a packet destined for some other network, it's going to try all these network addresses first. If it doesn't get a match, this network will match everyone. This is called the gateway of last resort, or the default gateway, or the default route. So right now, we know about the West network. This is 172.16.0.0/21. So right there, we know about the West. We also know about the WAN network, 172.16.16.0/30. That's right there. We don't know about East. So if we had a packet on this router that was destined for this network, right now, this router has no match for this network, so it would send it out to the internet. So it would actually never get over to this network. So we need to tell this router how to get to this network. So if we had a packet on this router destined for this network, we're going to send it out this interface, which is 172.16.16.1, and we're going to send it over to this gateway, 172.16.16.2. So we're going to close out our routing table. I'm going to highlight static routes and say new static route. So I have three interfaces. If I had a packet destined for the East network, we want to send it out the WAN interface. We want to send it out this interface right here. And the destination is the East network address, 172.16.8.0/21. That's this network right here. So that's the destination where we want to send it, where the packet needs to go. So we're going to send it to this gateway, 172.16.16.2. So we're going to send it out this WAN interface to this gateway to get to this network. We don't need to get it to the network. All we need to do is get it to this router. This router will take it from there. Click OK. Don't worry about the metric. That's the cost of the route. We're only going to have one route to this destination. I'm going to add a backup default gateway. So basically, if a packet is sent here that's destined for the internet, it's going to go out this WAN, this public interface. If that public interface is down, we want to send it across the WAN link. So this router will send it out this public interface. So it's going to be a backup connection to the internet. So what I'm going to do is do a new static route. Again, I'm going to send the packet out the WAN interface. The destination is a default gateway, which is quad zeros. And I want to send it to NAT2. That's the IP of NAT2. I'm going to bump up this to 500, the metric. And I'll show you why. So I'm going to look at my static routes now. I'm going to look at my routing table. This one, I have two paths to the internet, two quad zero routes. This one has a lower metric, so this is going to be the more preferred route to get to the internet. This one has a higher metric, and it will be less preferred than this one. If that public interface goes down, this route will get removed. And at that point, this route will come into play. So we have two different paths to the same destination, the internet. The one with the lower metric is the one that we're going to be using. Uh, so now I have an entry for my West network. I have an entry for my WAN network, and I also have an entry for my East network. So now we're going to go over and configure routing on that too. I'm going to open up Tools, Routing and Remote Access, highlight my router, configure enable. It's going to be a net router. If you get this glitch, press cancel, do it again. It's going to be a net router. It's asking for my public interface, which is public. It's asking for my private interface. I'm going to choose East right now and then add WAN when I get inside. I'm going to drill down into IPv4, NAT, right click, add a new interface, and add my WAN interface, which is a private network. And again, if I look at my static routes or my routing table, I can see I have an entry for the internet, I have an entry for East, and I have an entry for WAN. The reason why I have those two entries is because I'm directly attached to them. Any network that I'm directly attached to gets automatically added to my routing table. So I need to tell NAT2 about the West site. It's not directly attached to NAT2, so I need to tell it how to get to the West site. So I'm going to right click, do a new static route, and I'm going to send the packet out the WAN interface on NAT2, meaning I'm going to send it out here. And then I'm going to send it to this gateway on NAT1. So the destination network will be the West subnet, and the gateway would be 172.16.16.1. So again, if I had a packet that originated somewhere here and was sent to this router, and this router has to send it over here, we're going to tell it to go out the WAN interface and send it to the 172.16.16.1 interface on NAT1. Once it hits NAT1, we don't need to worry about it. NAT1 will take it from there. We just need to get it from here to NAT1. And again, the destination address is always the subnet address. This IP represents every IP in that subnet. And then we're going to add a redundant default gateway. So I'm going to add a new static route. If this interface goes down right here, I want to send all internet traffic across the WAN link to this router so this router can take it out this interface. So a default route is represented by quad zeros. I'm going to send it out the WAN interface and I'm going to send it to NAT1. So if I look at my routing table, I see I have two default. This one has a smaller metric, so this will be a more preferred route. And here's an entry for West. Here's an entry for East, and here's an entry for the WAN. So if we opened up a command prompt, that's an uppercase S. So this router has three network interfaces, this one, and this one. If I ping from here to here, it's automatically going to ping from this interface. By using the uppercase S, I'm defining what my source address is. So I want to say ping from here, route, send it across the WAN link, route again to this interface. So I want to ping from here to here, but I want to force both routers to route it so I know everything is working. So I have full connectivity between my two routers. So the next thing I want to do is configure my first DC. So while that's signing in, my first DC is going to be 172.16.0.2/21. I only have one network interface on this machine, so I don't need to go through and look at the MAC addresses. So if I have any computer in this network, this interface right here is my router to get out to the internet. So if any of these people in this network want to get out of that network to any other network, they'll send it to the NAT1, and then NAT1 will route it. So NAT1 interface will be my gateway. Because this is my first domain controller in my network, I'm going to point to my two upstream DNS servers, which I'm just using Google. Once I promote it, it'll pull these two IP addresses out and put in the loopback address in its place. These two will eventually become forwarders in my DNS server. Click OK. Click OK. Open up my firewall a little bit. And then I'm going to rename it. Again, always lowercase with the names DC1. Okay, I'm going to sign in. So DC1, DC2, DC3, and DC4 will all be domain controllers in my parent domain, which you don't know what that is yet. But in my first domain, I'm going to have 4 domain controllers. 2 over here on the east site, 2 on the west site. These machines will be handling DNS, policies, security, and authentication. So now I'm going to install the Active Directory software. I'm going to choose Active Directory Domain Services and the tools to manage it. No other additional features. Restart if needed. In this case, it is needed. After the next stage, it will reboot automatically because I checked it here. So I'm going to click Install. I'm going to pause the video while this installs. So now I'm going to promote this to a domain controller. Just a little heads up of what we're doing right now. I think I might be going a little too fast. Before we can set up sites, I need to get one DC up and running, and I need to have a physical connection between the two sites. So setting up the router, set up that physical connection between two sites. We simulated the WAN link. We don't really have an ISP, so this is a simulated WAN link. And so now I'm going to create my first domain controller because configuring sites is part of Active Directory. So I need an Active Directory forest to configure that site. So right now we're configuring this DC. What we just did before with the routers was configure the connection between the two WAN links and the internet. So we're going to configure this, configure sites and services. Then we're going to add another domain controller over on this side. So you can see that there's a DC on this side and a DC on this side. So what we're going to do is create a new forest. We're going to call it contoso.com. Our standard password, capital PA11WRD, capital PA11WRD. That's going to be our recovery password if this domain controller crashes. This is only good for this one domain controller. It's just like a recovery password should this machine crash. When you promote a machine to a domain controller, there's no local accounts anymore. So this will be the one password that'll get you in. Don't worry about the delegation. We do not control Google's DNS servers, so it's not going to allow us to create our DNS zone there. This is going to fail, and we're going to create the zone locally on this machine. We're not making any changes. Then I'm going to click install. It's going to take a good 5 minutes. So I'm going to pause the video. And when I come back, we're going to set up our reverse, then actually configure the sites. We're going to configure our reverse lookup zone that handles IPs to names. Okay, it's promoted. So I'm going to sign in. I'm going to go to Tools, DNS. You can see that it already added my folders for me. Those are my two upstreams. And if I look at my network card, I can see that it replaced those two IP addresses with my loopback, my IPv4 and my IPv6 loopback. So the DNS client on this machine will talk to the DNS server on the same machine. So I'm going to go back to my DNS. It also created my forward lookup zone that resolves names to IPs, but it didn't create my reverse. So I'm going to create a reverse zone. It's going to be a primary zone, meaning it's going to be part of Active Directory, part of the Active Directory database. So it'll get copied along with the database. And when another machine has DNS installed, it'll pull all this data directly from my Active Directory database. I'm going to send it to all DCs in my entire forest that have DNS installed. Eventually, these will all have the same. It's going to be an IPv4 network, and it's going to be for 172.16. So that's going to be one reverse for all three of these subnets. 172.16, 172.16, 172.16. So I went back to the class 4 address to create one zone for all three networks. There's really no reason to handle three separate reverse lookup zones on different DCs. So I'm just going to have one zone for all my subnets and then copy it to every domain controller. Click next, next, then finish. I'm going to open up a command prompt and do register DNS client. I'm going to exit this out. If I hit refresh, I now have a record for this machine. So now we're ready to set up sites. Again, a site is going to allow me to define two physical locations, and a lot of services are site aware, meaning if I have a DFS server on this side and another DFS server on this side, and I have a client here trying to connect to my DFS server, it'll automatically connect me to this one because that's in the same site. It's going to prevent the client from going across the WAN link to connect to this DFS server if this one is still up. So it's going to try to connect me to all machines within my same site before sending me across the WAN link, burning up traffic, burning up bandwidth and dollars. Also, sites allows me to define that all these domain controllers replicate to each other, all these domain controllers replicate to each other, and only DC1 and DC3 will replicate with each other. I'm not going to let 4 replicate with 2 and 5 replicate with 4 and 6 replicate with 3. I want to control that replication. Again, my goal is to try to cut down on traffic going across this WAN link. So I want to keep all the traffic that I can local, all the traffic that I can local, and then only allow 2 machines to replicate to each other. So all these DCs will replicate to this DC. All these DCs will replicate to this DC, and then this one will replicate it over here, and this one will replicate it over here. So I'm going to even control replication traffic that goes across that WAN link. So I'm back on DC1, so I'm going to go to Active Directory Sites and Services. I'm going to expand site, and I'm going to rename this default first site West site. No, I can't have a space. I'm just going to call it West. And then I'm going to create another site. I'm going to highlight sites and create another site called East. And then I have a default site link, and I'll explain that in a minute. Now it's giving me a warning that I need to configure subnets. So I need to create subnets and associate those subnets with sites. So when a client is in this subnet, it knows what servers are in that same subnet. And this one will do it as well. So it's going to make sure clients in this site talk to servers in this site. Clients in this site will talk to servers in this site. The only time it's going to go across the WAN link is when I don't offer that service on this site. So I'm going to go to subnets. I'm going to create a new subnet. 172.16. 0.0/21. That's my west. So I'm going to associate that with the west site. Then I'm going to create another subnet. 172.16.8. Guys, I don't have to put the last zero. I can put just /21. It'll figure it out for me. That's my subnet for my east network. I don't really need to create a site for the WAN because I don't have any clients in this network. I won't have any clients or servers. There's only two hosts, one for this router and one for this router. Okay, so we have two ways to send data across the WAN link. Through IP, our normal IP, or through SMTP, Simple Mail Transfer Protocol. If I had a satellite office and it had a really slow link, like a dial-up connection between my main site and my satellite site, then I might not want to use IP. I might want to use SMTP, where if I need to replicate data over to the other site, I can email it to them. That's what SMTP is. What we're going to use is IP, and it creates a default site link. When you promote it to a domain controller, it automatically creates this. I'm going to rename it to east to, I'm going to east and west. So I know what it connects. And this site link allows us to control a preferred site link. I might have multiple site links, and which one will be preferred? I can't remember if it's the lowest cost or the highest cost, but the lowest cost, I believe, is the more preferred route. It's going to tell you how long you can replicate. Um, by default, it's 180 minutes. We don't want replication to occur any quicker than that. If you create a user account here, how quickly do you need that user account to be over here? If you add a document to this DFS server, how quickly do you need it to be over here? That's going to affect what you adjust for this replication frequency. I'm doing it 15 minutes because for this lab, I don't want it to take 4 hours for something to get over to the other side. We'll never be able to do these labs. And I can also dictate when I want replication to occur. Maybe I don't want replication to occur during business hours. I only want to allow it to replicate in the evening or on the weekends. So I can also control replication that way. So the only thing I've changed here is I dropped it down to 15 minutes because the nature of what we're doing in this practice lab, if we wait 180 minutes, it would drive you crazy. So I'm gonna click OK. So automatically DC1 was part of the default first site, which we've renamed West. So now what we're going to do is we're going to promote DC3 and it's automatically going to fall into the east site. Then I'll show you as we go along, I'm going to show you how important this interface is when dealing with replication and things like that. But we'll come back to this after DC3 is promoted. So our next step is we're going to go to DC3, sign in, configure IP settings, configure the host name, install the software, then promote it to a domain controller. So our IP address for this machine will be 172.16.8.2/21. I'm going to pause this while it's signing in. Okay, I'm going to go to local server. One 172.16.8.2/21 for my subnet mask. My gateway is going to be my NAT2 router. On my DNS server, because I already have DC1 configured, I'm going to point this to DC1. We know that we have connectivity between our two sites. So this is going to go to DC1 to learn all about the contoso.com domain. I'm going to rename it DC3. I wanted to do this in PowerShell, but I forgot. And reboot. I'm going to use PowerShell to promote it to a domain controller. This is going to be a new domain controller in an existing forest. Actually, I'm going to erase this. I'll show you why. I think it's a little easier to read if I put it up here. That's the Active Directory domain services. Include management tools and restart after I promote. So I'm going to highlight that and press play. Uh, Maybe I have the name wrong. So git hyphen ad domain. Sorry, I had the name wrong. While that's installing, I'm going to keep typing. Actually, I can't tab complete till this is done. I'm going to pause this for a minute. Okay, it's done installing, so I'm going to take my password, capital PA11WRD, and encrypt it and save it in that variable. Then I'm going to install AD DS domain controller. The domain name is contoso.com. My recovery password is capital PWD. And force, so it doesn't ask me. I don't need to do a reboot because the reboot is up here. So I'm going to highlight these two lines. So instead of going through that, I have to supply credentials. So instead of going through that big long wizard to promote a domain controller like we did on the first machine, we can just run these two commands, which, guys, I don't remember. So don't try to remember. I'm using the tab complete. Um, After a while, you'll realize there's too many commands to remember. It doesn't like that in that format. So I have to do get credentials, and I'll explain what's going on here. So if I just supply my user account name in plain text, it couldn't understand it. So what I had to do was I had to create an authentication object. So I'm going to run this command. It's going to throw up a dialog box, ask me for my password. When I click OK, it's going to save that as an authentication object, then supply that here. So here it's going to pop up a box, ask me for my password. When I click OK, it'll save it as an authentication object and then promote it to a domain controller. The reason why I need to authenticate is because I need to connect to DC1 to turn this into a domain controller. So I have to supply domain credentials to do that. So I'm going to pause this while this is doing its thing. Okay, DC3 is promoted. So I'm going to sign in. If I open up sites and services, I can see that this machine is already aware of the sites. DC3 is automatically populated in the east site. DC1 is populated in the west site. If I go to DNS, I can see I have my forward lookup zone with DC1 and 2 in it already. And I can see that my reverse is already there. If I go and look at forwarders, I can see that if I don't know the answer, I'm going to send it directly to the upstream servers. There's no reason to forward to DC1 because DC1 and DC3 have the same information. So if DC3 doesn't have that information, it's going to send it directly to the upstream. And as far as my DNS client is concerned, it's going to point to myself and then as a secondary point to DC1. Actually, it didn't do it just yet. If I give it a little bit of time, it'll fix itself. It pointed to DC1 as the primary and myself as the secondary. I could reverse those if I wanted to. And so DC, my IPv6 is the first DNS server I'm going to use. So it's going to first point to my IPv6 DNS server, which is on the same box, the loopback, then DC1, then back to myself IPv4. Those are my three DNS servers. Myself, DC1, then back to myself. Okay. Windows AD. Um, okay. So we have something called the KCC. It stands for Knowledge Consistency Checker. So basically, when domain controllers replicate to each other, it's the KCC that defines that replication topology. And this stands for Knowledge Consistency Checker. But we don't want KCC to define our replication topology across the WAN link. We have um, DCs over here. We're going to have DCs over here. We want to define which machine is going to replicate across this WAN link. So we're going to go back into DC1. Now DC1 might not have the same information as DC3. So I'm going to try to do a refresh. Okay, it does have the information. DC3 won't show up here immediately because we have to wait that 15 minutes to replicate. So I'm going to highlight my server, DC3. I'm going to go properties. Then I'm going to make for IP. Remember, we have two two site link technologies, IP or email. So for IP, I want to make it a bridgehead server. So what I'm saying is for this site, we're going to make it so only DC3 will replicate across the WAN link. And we'll need to turn DC1 into a bridgehead server as well. Because if you only have a bridgehead server at one side, it's not going to work. We need to define a bridgehead server on each side, and there's only those two machines will be allowed to replicate to each other. Now, those machines that you label as bridgehead servers need to have more memory and more CPU power than the rest of the DCs. Because when we transmit data across this WAN link, we want to make sure it's encrypted. So any machine that you've labeled a bridgehead server is going to encrypt the replication traffic before it sends it across the WAN link. Then the bridgehead server that receives it will decrypt it. So because of that encryption, this needs to have more CPU and more memory so it can decrypt and encrypt that replication traffic as it crosses the WAN link. Remember, we don't control this. This is controlled by our ISP. So we don't know what path it takes before it gets to our other site. So we need to make sure it's encrypted. So the bridgehead server serves two purposes. It defines that machine as being allowed to replicate across the WAN link, and it also encrypts the replication traffic before it sends across the WAN link. Then the receiving bridgehead server will decrypt it. So if you have multiple domains, you need to define bridgehead servers for each individual domains. Right now, we only have one domain. So we're going to make DC3 a bridgehead server. And we're also going to make DC1 a bridgehead server for the IP transport protocol. So if I highlight if I highlight servers, I can see that DC1 is the bridgehead for the west site. If I highlight servers on the east site, I can see that DC3 is the bridgehead for the east site. I'll go into what this is later. This is called a global catalog. This is important, but I don't want to talk about it now. So, guys, with these videos for this class, I'm going to try to make them more condensed. I'm not going to have multiple videos. I'm going to try to be as straightforward as I can. So, this is the first video for sites and services. Before we could do sites and services, we need to have the infrastructure in place, which was two routers to connect the two sites together, and we needed to have a DC on each side to show that uh, setup for sites and services. As we get down, we're going to be playing with sites and services more once we add more domain controllers and we can see what we can do with it. I cannot stress this enough. For this particular class, you have to be patient and you have to give it time to replicate the traffic. Because when you do something on the west site, it's not going to appear immediately on the east site. So you have to give it time before it replicates over to the other side before you move on. Okay, guys, that's it for this video, and I will see you in the next video. Thank you.